Okay, welcome to this next tutorial. Today I'm going to show you how you build this scene here. So in the first video you'll see how you insert the conveyor belts and the proximity sensors and how you make the belts work properly. Then in the second video will be a little bit of theory about inverse kinematics, and then last, in the third one, you'll see how you insert this robot arm and how you make the motion possible here. So let's start. First, yes, I updated my VREP version, so I'm using 3.6.2 now. Okay, let's stop the simulation and close this scene. Start with a new scene. And to make things a little bit simpler, just go to my GitHub page. There you will find a file called modeling parameters, and it will tell you where you have to place the objects and how you have to orient them. It's just a little simpler. Okay, so let's go to the model browser and insert this conveyor belt here. Go to equipment, conveyor belts, then scroll down. I'm using this conveyor belt very efficient. Okay, then let's set the position to -0.7, -0.5 and 0.1. Okay, then next conveyor belt will be this customizable conveyor. Drag and drop it in here, and now let's modify the geometry in the GUI. So this is 1.5. Here we're going for the minimum. So okay. So close this and let's set the position 0.5, 0.4, 0.18. And this also needs to be oriented correctly, so place 90 degrees here. Okay, now let's insert the proximity sensor. Right click, add proximity sensor. Let's insert the ray type one and specify the type later. Okay, we don't need the model browser anymore, I guess, so open up the scene hierarchy. Let's rename this belt 1, and orientation is -90, and position is 0.2, -0.5, 0.25. Okay. Then let's specify the parameters of the proximity sensor. So double click this icon, and we are interested in show volume parameters. Click here. Change the type to cone. So we want to have a cone here. Cone. Offset is 0. That's okay. Let's set the range to 0.2. Radius is okay. And let's set the angle to 45 degrees. Okay. Let's add the next proximity sensor, ray type, and I simply copy and paste this one in order to get two of them. So we need two proximity sensors for the second belt. Let's rename these. Belt 2, belt 2, belt 2, 1, range 0.2, okay, and let's change position of the first one. 0.5 minus 0.45, 0.24. Okay, the orientation minus 90 in X. Okay, select the second one, range 0.2. I don't know why this this becomes black all the time. It's super annoying. Sorry for that. Close this, and this has 90 in X. This has 180. Okay, and position in X is 0.5, 1.35, and 0.24. Okay, let's create first dummy. Right click, add dummy, rename this, call this release pause, and orientation is 180 and 90, and the position is 0.5 minus 0.25, 0.4. There it is. I guess the orientation is not correct. 180, 90. Okay, you will see why we need this dummy in the last video. Okay, let's create the next dummy and call this box dummy. Create a primitive shape cuboid. This will be our box. 0.1 in X, 0.15 in Y, 0.1 in Z. It's okay. Let's call this box. And now simply select this and let's translate the dummy along Z. A little bit upwards, somewhere here. Yes, and the dummy, box dummy, also need to be oriented correctly. Again, you'll see why in the last video. So this has 180 and minus 90. Okay, and in order to have the box and the box dummy nicely together, and to be able to connect to the box dummy, you will see it in the last video, you will need to drag and drop the box dummy into the box. And you see, if you start translating the box, the X and Y plane, the dummy will also move. Okay, we will not insert the robot. This will be for the last tutorial. So let me show all of the scene, and now we can start scripting. And I'm going to do this using a template, and you find the template again on my GitHub page. Get back, go to tutorial 1, and here you see two versions of the child script for the conveyor belt. One is commented and one is the final one of this first tutorial. So what you could do is open up these two child scripts, the uncommented one, raw, and then simply copy this one, it's the customizable conveyor, and open up this, select all, paste. Okay, let's open up this, go over here, all. Okay, and then when you hit play, see, it sort of works, sort of, but the proximity sensor doesn't seem to detect the objects. So what you need to do is go to the scene object properties, so double click this cube, scene object properties, then go to common, and here you need to select or check the detectable checkbox. Okay, so let's hit start again, and you see it sort of behaves as expected. But you know, it didn't learn a lot. So let me insert the commented version and add more and more functionality, so you really see how you would go ahead and program this. Close this, commented, and by the way, I recommend to do the same, so to use this commented one. What was that? Customizable. Okay. And here, okay. Conveyor. Now, if you hit play, nothing happens, but you have no errors. That's important. Okay, so let's start on commenting the conveyor belt child script. Double click the child script, and here you see syscall init. This is the initializer function. This will be called once when the simulation starts, and usually you define your global variables and your handles to the objects here. So let's start with the user parameters. So this is simply belt speed. It's what it is, 0.4 meters per second. This T insert is the insert period. This means at every second an object will be inserted here. Then here we have the insert coordinate. So this is the rough coordinate of where the object is inserted. This is a table. It contains 3 entries, X, Y, and Z position. Okay, so these 3 numbers correspond to a position somewhere around here. Then the good percentage is simply the percent of objects that is considered to be good. And what is good? Good means that the object has exactly this color. So this again is a table, but here it contains red, blue, and green components. And if you look at this color, it has a lot of green, so this is a greenish one. Okay. Then here we have some auxiliary variables. You will see why we need this t last inserted. I will not explain it now. Also this delta time and this has stopped flag. Then here we initialize an empty table for the boxes and the empty table for the dummies. And what this will be is it will store the object handles to the box and to the dummy that are present on this belt. So this is a dynamic table. We will also introduce a bool list, and this bool list will contain bools. And if the corresponding bool is false, it means the object is bad, and if it's true, object is good. Okay. Then here we initialize the handles to our box object and box dummy. So the handles to this one. Okay. Then the handle to our proximity sensor. Handle to this. Then here we get a handle to this script. So we will not use it in this tutorial, but you can use this to execute functions in this child script, but call it from this one. And here we simply set the belt speed of our conveyor belt. So this sim self-handle is actually pretty simple. It simply returns the handle of itself, and then you get the script simulation parameters. And maybe you remember from the crane tutorial that these parameters are stored in here. So double click here and you see script parameters, conveyor belt velocity, and we will set this value here. Okay, so conveyor belt velocity, belt speed. We have specified it over here. And then at the end of the initializer, we will call the insert box function. So at the start of the simulation, a box will be inserted here. So let's find out how we do that, how we insert this box. So hit play, see, no errors, that's good. And let's search this insert box function. It must exist since we have no error. And here we are, insert box. Let me zoom in a little bit on this box. Okay, so first I would really like to show you how you insert objects. And you can't actually insert objects, but you can copy and paste existing objects. And we will use this like as a template, and we will keep on copying and pasting this object. And this is done in line 112. So you see local variable insert objects. Function name is sim copy paste object, and you simply feed in a table of object handles that you want to copy. That is why we need the handle to the box and to the box dummy. And this will return another table with the same dimension, but it will keep, or it will store the handles to the new objects. So let me hit play and show you what happens. You see, it's real time. So the box or the copy is pasted at the exact same location, and since these are dynamic objects, they sort of repel each other. So how do we modify the position? So we would like to insert this one somewhere around here, and maybe you realized that the position was slightly disturbed, so each object was pasted at a different position and different orientations. So let me show you first how you do this. So what we need is, we need 3 random numbers, and you can do this by calling math.random, and this will simply return you a uniformly distributed random number in the interval between 0 and 1. Again, another one and another one. So with the random number 1 we will disturb the x position, 2 will disturb the y position, and the 3 will be for the orientation. Now what you can do is, you can call this local dx for disturbance in x. Then when you multiply this random number by 2 and subtract the 1, then you will get a uniformly distributed random number in the interval between -1 and 1. And then you can scale it with a proper number, such that, you know, it's not pasted somewhere not on the belt. So do the same for the y and do the same for the orientation. Just use another scalar here. You know, you can play with these scalars as you like. Then we define a vector that has 3 zeros, or a table, and simply modify the entries of the table. So let's start with the first one, and you see Lua starts indexing by 1, and I don't really like that, but that's the way it is. So simply use the insert coordinate. So this is the rough coordinate we have specified here in the initializer, use the first component of this and add this small disturbance to it. Okay, do the same for the Y and leave the Z component undisturbed. Doesn't make any sense to disturb the Z direction. Okay, and now we're able to set the object position. So here sim.setObjectPosition, get the handle to the newly created object. So this comes from here. Use the first one, it will be the copy of the box. So this is the object handle to the box. Here -1 indicates that we are using global reference frame, and then simply plug in the disturbed coordinates we have defined. So if you hit play now, you see the object is really inserted and is disturbed in X and Y. Now you can do the same with position and orientation. So simply sim.setObjectOrientation, again handle to the box, also global reference frame, and here simply plug in a table with the corresponding rotations. So we only want to rotate it around Z by d phi. Okay. Then we need to, this is for bookkeeping, so we need to insert the dummies we have created and the box, the handles to the dummies and the box. We need to insert them into our box list and our dummy list. And this is simply by table.insert, then give them the table that you want to use, and simply insert the handle to the object, and here insert the handle to the dummy. So we are able to keep track of what object is on the belt. Okay, and now let's decide if the object is good or bad. And we do this by creating another random number. Let's call this decision. Then here, if decision is less or equal to a good percentage, then we can say that the object is good. And otherwise, the object is bad. And this is really introducing this probabilistic behavior. Okay, so if we are in this case, so it means the object is good, then we can assign it the correct color. So this is the green color we have specified in the initializer. This is done by sim.setShapeColor, then given the handle to the object, this is the box. Second argument, you can make it nil, so it doesn't matter. Third argument is the color component, so we will use ambient diffuse components. Maybe you remember from the crane tutorial that we also used ambient diffuse. And here simply plug in RGB table. This is the color we have already specified, as I already said. Then otherwise, so in 81% of the times on average, this else block will be active. Then we want to set the shape color to a random color. So again, handle to the box, nil, ambient diffuse. And here, simply reuse the random numbers we have created over here and create this this table with 3 entries, RGB, and it will simply assign a random color to the box. And of course we need to update our bool list. So if the object is good, we will insert a true in our bool list, and otherwise we will insert a false. Okay, so let's hit play, and you see the objects are colored. Let's see if we can, yeah, this is a good one. Okay, now let's go to the last part, to the sensing. You know, we will not modify this syscall actuation. It's not part of our tutorial, but it is here to make the conveyor belt work. Okay, so don't modify this. You can close this if it's confusing. So let's continue with this syscall sensing. And the syscall sensing is executed one time, so at each time step. So here we have 50 milliseconds, so this function will be executed every 50 milliseconds. And you gotta be a little bit careful that you don't have a lot of code in here or some waiting times, since it will stop the whole simulation and it can slow down the simulation. Okay, so first let's read the proximity sensor, this proximity sensor, and this simply by sim.read proximity sensor and feed in the handle to this proximity sensor. And then this res will be 0 if the proximity sensor does not detect anything, and it will be 1 if it has detected an object. Now let's see if we are able to insert a new object. So when can we insert a new object? And here you see why we need this t last inserted. So what we do is we say sim.getSimulationTime, and sorry, let me go down here, since I forgot to, to the insert box function, since I forgot to do this one. Sorry for that. So after we have copy and pasted our objects, we need to get the simulation time at which we have inserted the object. So by this we are able to determine when we can insert the next object. Okay, that makes sense. So uncomment this. Now we can go over here again. Now we get the actual simulation time, and if we subtract the simulation time at which the last one was inserted, last box, and this is greater than our insert period, then we are able to insert the next box. Okay, that makes sense. But there is another condition, and this is this has stopped flag. So this is either true or false. And if this is false, this means the belt is still running, then we are able to insert the box. So we don't want to insert boxes when the belt is not running. Okay? And now let's see, or let's make this conveyor belt working. So if the proximity sensor detects a good object, we would like to stop, and if it detects a bad one, we would like to remove it. So what we need is, first let's see if the proximity sensor has detected anything. So if res is equal to 1, if it has detected something, and not has stopped, then. And this means that this proximity sensor has detected an object, but the belt is still running. Okay, so then we are in this case. Proximity sensor has detected something and still running. Okay, first let's see if the object is good or if it's bad. So if bool list, so if the first object of this bool list, it will be the first one that appears here. If this is true, so it's a good one, then here we would like to stop the conveyor belt. So here it's the same function as we have used in the initializer. Simply set the conveyor belt speed to 0. And now we need to store a delta time. And we need this because Now imagine the situation when an object arrives here, a good object arrives here, and before the belt stops, an object gets pasted here. Then time goes on, and eventually this good object will be removed, and the belt will start running again. But then the delta time here will be so large that another object will be inserted on top of the object that is already here. So in order to prevent this and to have even spaces, we need to know how long do we need to wait when the belt restarts to insert an object. I hope that was clear. Okay, so this is what we need. And then we can set the bool has stopped to true. And you see what it's doing. So now this is true. And if an object is present here, a good one, this function will not be, so we will not get in this if clause since this is true. That's why we need this. Okay, and otherwise, so if we are dealing with a bad object, first we would like to get the handle to the object and the handle to the dummy, and simultaneously remove the object or remove the number from our table. This is done by table.remove. Very simple. So feed in the table that you want to use and tell them at which index should be removed. So the first one. And this will, it's a cool thing, it will return the handle that was removed. Okay, so it will return the first handle. Same here. And then here simply remove the bool list. We don't need the information. And in order to completely remove the object from the scene, you can call sim.removeObject and then feed in the handle to the object that you want to remove. Okay, and now here this is the situation if the proximity sensor doesn't detect anything but the belt has stopped. So that means there was a good object and something removed the object, you know, a robot or something. Okay, then we say res is equal to 0. If res is equal to 0 and has stopped, we would like to restart the belt, right? So sim.setScript simulation parameter, restart the belt. It's the same as we have done over here. Simply feed in the belt speed. Set this has stopped to false, such that it's able to get in here again. And last, set this t last inserted to sim.get the actual time minus the time we have to wait. So this one will not shoot right after the belt restarts. Okay, that's it. I mean, now it should work. So this should work. Let's see. Shouldn't have told this real time. Okay, works. Good. Let's go to the second script. Customizable conveyor. So this is the same, you know, init, initializing. Let's keep track, so belt speed, that's clear. Let's keep track of all the objects that are present on this conveyor belt. Then these two variables come from the actuation code, so we don't need this and don't modify these. Then get the handles to the proximity sensors. Get the handles to the first belt. I'm not sure if we need that, but let's do it. And here, you know, simply set the belt speed to whatever we have in here. So nothing new here. Now let's modify this syscall sensing function. First, read the proximity sensors. And then what we want to do is, if an object is detected by this first proximity sensor, we would like to start the belt, and as soon as the object is no longer detected, we would like to stop the belt. That is super easy. So if prox is equal to 1, if it has detected something, let's start the belt. So, you know, simply plug in the belt speed, otherwise stop the belt. So let's see, we can test this. Move this along X and Y somewhere here. I'll play the simulation. Let's move it along Z. And you see, as soon as an object is here, it will start moving. Okay. So, and for second proximity sensor, we would simply like to remove the object that is here. And again, nothing new. So if this proximity sensor 2 detects something, call this function remove object, and this function is over here, remove object, sim.remove object. Then in here you can simply say table.remove box list, remove the first item from the box list. It will return the handle to the box, then simply remove the box, and do the same for the dummy. And last but not least, let me introduce this add object function. So this we will use in the third video. And you have already seen in this conveyor belt child script that we will call functions from this child script. We will call a function that is located in this one, and it will be this add object function. And what this does is simply it will receive a table with 2 entries. So the 2 entries will be the handles to the box and the box dummy. And we will simply table.insert these handles into the box list, insert the first handle into the box list, and insert the second handle into the box dummy list. Super simple. And in this way you can use the handles that you have in here and simply tell this conveyor belt which box and which box dummy will arrive next. Okay, that's it for this first video. So in the second one will be a little bit theory, and in the last one you will see how you insert the robot and how you finish up the scene. I hope you learned something, and see you later.